Example 10.12. Here we have simply a pulley of mass m, of radius r, and of moment of inertia I. A light cord wrapped around the pulley and attached to the mass m. I need to calculate the angular acceleration of the pulley. I calculate the linear acceleration of the mass m and the tension of the cord. Let me explain some points before. Here, you know, I can take 1 point here, one point here, for example. We have point A, and here we have point B. If we have a rotation, so A will do a circular rotation on the, okay, we can say like this. Anyway, here we have a circular rotation of radius equals to r. So VA must be tangent to this trajectory. Here we have VA. And B will do another circular trajectory around the axis with a radius equals to RB, and the velocity is tangent to the trajectory equals to VB. You know, at time t, we have omega and we have alpha. VA, here we can say omega A equals to omega B equals to omega, and alpha A equals to alpha B equals to alpha. This is the first point. The second point, you know, VA is not equal to VB. Why? Because VA equals to R omega and VB equals to RB times omega. We have the same omega, but R is not the same, and V is not the same. The same thing for A tangent equals to R times alpha, and A tangent of B equals to R times alpha. We have the same alpha, but not the same radius and not the same A tangent. The second point. The third point, you see here that the cord is passing at the point A. So the velocity of the point A is the same as the velocity of the cord, okay? Because it's passing through the point A. It's not through the point B. It's not through this point. So here we can say simply V of A of the point A equals to V of the mass m, and A tangent of the point A equals to AM. Okay, this is a very important point. The fourth point, you know, here we have a rotation anticlockwise. When we have anticlockwise, it's a positive direction, and the negative direction will be opposite. Okay, so here we can take only one positive direction of all the system. So here we have the positive for the pulley, and here we have the positive for the mass M. Okay, This is about the direction. The last point, in the case of linear rotation, linear motion as the mass m, we use summation of F equals to ma. In the case of rotational motion, we use summation of tau equals to I times alpha. I need to calculate A, I need to calculate alpha, and after I need to calculate T. We have a relation between A and alpha, so the third relation will be A tangent equals to R times alpha. Okay, I take the point A. The point A. A tangent of A equals to R times alpha, R for the point A. We have 1, 2, 3 relations. We can solve the problem by using these equations. First of all, I need to calculate alpha. You know, we have to use this relation because we have alpha. Okay, so we can say summation of tau equals to I alpha. What we have tau of t, the tension. I am talking now just the pulley where we have the rotation. Tau of t plus tau of the weight of the pulley plus tau of the reaction at the axis. Here we have the reaction and here we have the weight. Okay, equals to I times alpha. You know, mg and r passes, we can say here tau of mg equals to tau of r equals to 0. Why? Because passing through the axis. Okay, any f passes through the axis doesn't have the torque, toe. So we have only tau of t, which is equal to I times alpha. What you have to do now, here you have to precise the direction. Okay, I said here, this is a positive direction. You know, T rotates the object or pulls the object down. So it's in the positive direction. So we have to say plus tau of t. For example, if we have another F here applied on the pulley, this F rotates the object in the negative direction. So you have to put here minus 2 of F. Okay? So okay, plus we have plus 2 of t equals to I times alpha. You know, here you have to put the absolute value of tau. You know, it's equal to r times t. R is the distance between t and the axis, and t is the value of t, which is equal to I times alpha. So we can say alpha equals to r times t divided by I. This is the value of alpha, but it's in function of t. We have to calculate t later. Okay, so we can write here simply the first equation, alpha equals to RT divided by I. The second equation, I need to calculate A. I said before that A of the mass M equals to A of the point A here. A tangent A. Okay? To calculate A, I have to apply Newton's law on this object. So we have summation of F equals to ma of the mass m. What we have T and we have mg applied on the object. You know, we have the positive direction is like this. So T is in the negative direction and mg is in the positive direction. We can say plus mg minus T equals to ma. You know A here, am. So we can write here the second equation, am equals to mg minus T divided by m. You know, we have T and here we have T. We have to find another equation in order to calculate T. Okay, first of all, we used this equation. The second, this one. Now we can use this one to find the value of T. You know, we have A tangent of the point A, which is equal to A of the mass M, equals to R times alpha. We can use alpha here. We can say AM equals to R times alpha, RT divided by I, which is equal to T R square divided by I. This is the third relation. Okay, so we can say AM equals to TR square divided by I. Okay, as you see here, we have AM and AM. We can say equation 3, equation 2 equals to equation 3. We can write mg minus T divided by m equals to T R square divided by I. As you see here, we have only one unknown, T. We can calculate T. When you calculate T, we can put it here to calculate AM and here to calculate alpha. So here we can write mg times I minus T times I equals mt r square. So we can take T as a common, m r square plus I equals to mg I. So T equals to mgi divided by mr square plus I. This is the equation 4. So now we have all the equations to calculate okay. I want to calculate now alpha. We substitute 4 in 1. Okay, we get alpha equals to r, I put t here, divided by I, t equals to mg I divided by mr square plus I. We can eliminate I and I. We get alpha equals to r mg divided by I plus mr square. This is the final value of alpha. Second, we substitute now the value of t in the equation 3. Okay, we can say 4 in 3. We get am equals to r square divided by I times t, which is equal to mg I divided by mr square plus I equals to, we can eliminate I and I. We get finally mg r square divided by, okay, this is the final value of am. So here we have am, here we have alpha, and here we have t. Okay, the most important point. Here we have a lot of calculations, okay? It's not important. You have to understand the keys of the solution is this equation and this one and this one. If you know these relations, you can solve any problem.